Let's talk about STEAM education. First, what is STEAM? It's a trend in science education where you take science, technology, engineering, art, and math together with the intent of helping students with sense making to increase their understanding and creativity. I'm first going to look at some research, and then I want to go into how to implement that into my classroom. I found 3 articles because the first one you see on the left, I felt like wasn't from the most reputable source, but the other 2 are. So I used all 3 because I really liked what was being said in the first one. It was a university in the Philippines tested how to teach educators to teach astronomy using art. It yielded very profitable results in helping people to understand intangible concepts. And I think that's really cool in science education to use art to help with the intangible. The next 2 articles both come from a periodical called Art Education. The first one talks about how marrying art, science, and technology can help with developing student creativity, which promotes students to think like a scientist, understanding the nature of science and scientific practices. The third article from that same periodical talks about how to implement STEAM into PLC meetings. So you're taking educators that don't normally work together in a PLC, science educators, art educators, and how to work together to develop curriculum that promotes sense making in science. That brings me how to implement this in my classroom. For me, this was a flip of a switch. Using art as a phenomenon, which instead of using art to explain science, you're using science to explain art, which is really hard for me to grasp at first, but I really, really like it. STEAM is a way to use core disciplinary ideas. So it's a way to reach students that you wouldn't normally reach, I think, by connecting key concepts between subjects. So I would use this for visuals, diagrams, modeling, creativity, allowing students ways to represent their sense making that they wouldn't normally be able to, including displaying it in class and then using technology to create art. This brings me to a standard and a possible project that students could work on. I use the high school standard, use mathematical and computational representations to predict the motion of orbiting objects in the solar system. You can see here these really beautiful spirographs created by drawing lines between Earth or other planets and other objects in our solar system throughout their orbits. I think it's really beautiful, and it's definitely art, but it's science. And you use technology to create this. I created my own. That's what you see here on the left. This is one using Earth and Mars. And if you go over here, this is how students could create their own. Internet is fast enough. So right here, this is Earth and Mercury. You can speed it up, and it creates their own spirograph of the orbital patterns of Earth and Mercury. This can be used to incorporate that standard, obviously, which uses Kepler's laws and gravitational motion, and then also a bit of coding if students wanted to write their own code to make this piece of art. An alternate, which is a little bit simpler, maybe used for middle school, would be to use these spirographs. And I didn't have one to make my own, so you get to look at this GIF of it, which models one object orbiting around a central location, as you can see with the star Sirius right here. And then you can make your own. And then shifting gears just a little bit, you can see the work of Robert Gary, who is a famous architect who I kind of fell in love with a couple years ago. And he marries art and science by developing these really beautiful art concepts. So you see right here, the Disney Opera House. And then he goes back and he develops software and engineering and architecture to build these in real life. And it's just absolutely beautiful. So I hope this helps understand a little bit more about STEAM education. Stop the recording.